On March 15, 1970, 43 seamstresses clocked in for their morning shift at the Peachtree Cotton Mills in Columbus, Georgia. By 2:47 that afternoon, 12 of them would never clock out again. 12 women, ranging in age from 19 to 54, would lose their lives when a catastrophic structural failure brought down 3 floors of the textile facility in less than 30 seconds. 12 families would be shattered. 12 empty chairs at dinner tables. All because a critical support beam inspection had been postponed for 6 months to avoid disrupting production quotas. If you want to understand how this preventable tragedy claimed so many lives and forever changed workplace safety standards in American manufacturing, subscribe to this channel. This episode is a fictionalized reconstruction inspired by real manufacturing accidents and workplace safety investigations. Names, locations, and specific events have been created for storytelling purposes. The humid Georgia air hangs thick around the red brick walls of Peachtree Cotton Mills on this unseasonably warm March morning. Temperatures climb toward 82 degrees, unusual for mid-March, making the already stifling factory floor nearly unbearable. The rhythmic clatter of 230 sewing machines creates a mechanical symphony that echoes through the cavernous space, punctuated by the hiss of steam presses and the whir of industrial fans that push the heavy air around but provide little relief. The smell of cotton dust mingles with machine oil and the faint sweetness of sizing starch, creating the distinctive aroma that every textile worker knows intimately. Built in 1923, the 5-story facility stretches across 4 city blocks in Columbus's industrial district, employing over 800 workers across 3 shifts. The building's impressive facade, with its decorative brickwork and tall windows, masks the cramped working conditions inside. Each floor houses different aspects of textile production, from raw cotton processing on the ground level to finishing and packaging on the 5th floor. The 2nd, 3rd, and 4th floors contain the heart of the operation, where hundreds of seamstresses work at closely spaced stations, their machines arranged in long rows beneath banks of fluorescent lights that buzz constantly overhead. The economic boom following World War II has created unprecedented demand for American textiles, and Peachtree Cotton Mills has expanded rapidly to meet it. The facility operates at full capacity 24 hours a day, 6 days a week, producing everything from work shirts to military uniforms. The company employs primarily women, many of them supporting families while their husbands work in the region's steel mills and manufacturing plants. For these women, the mill provides steady employment and decent wages by 1970 standards, though the working conditions remain demanding and the pace relentless. The building's structural history reveals a pattern of modifications and expansions that would later prove significant. Originally designed as a 3-story facility, 2 additional floors were added in 1945 and 1952 to accommodate increased production. These additions required modifications to the original steel frame support system, including the installation of additional load-bearing beams and columns. However, the building's foundation and lower structural elements were never upgraded to handle the increased weight and vibration loads from the expanded operations above. Safety records from the 1960s show a troubling pattern of incidents at Peachtree Cotton Mills. In 1963, a section of flooring on the 3rd level sagged noticeably, requiring emergency repairs and the temporary relocation of 30 workers. 2 years later, several workers reported feeling the floor vibrate excessively during peak production hours. A consulting engineer recommended immediate inspection of the building's structural supports, but the assessment was delayed due to concerns about production interruptions. In 1967, cracks appeared in the walls of the 2nd floor, prompting another recommendation for comprehensive structural evaluation. Again, the assessment was postponed. The facility's maintenance records reveal a culture of deferred repairs and cost-cutting measures. Critical infrastructure improvements were routinely delayed or canceled to maintain profit margins and meet production deadlines. The company's safety committee, established in 1965 following a minor fire in the cotton storage area, met sporadically and had limited authority to enforce recommendations. Union representatives repeatedly raised concerns about working conditions, but their complaints were often dismissed or addressed with minimal temporary measures. Federal workplace safety regulations in 1970 remain limited compared to later standards. The Occupational Safety and Health Act will not be signed into law until December of this year, meaning oversight of workplace conditions relies primarily on state inspections and voluntary compliance. Georgia's industrial safety standards focus mainly on fire prevention and basic machinery safety, with little attention to structural integrity issues in older buildings. Insurance inspections occur annually, but tend to concentrate on fire hazards and liability issues rather than comprehensive structural assessments. The women who will lose their lives in the coming disaster represent a cross-section of the local community. Supervisor Dorothy Williams, 54, has worked at the mill for 28 years, starting as a seamstress and working her way up to floor supervisor. She oversees operations on the third floor and is known for her meticulous attention to quality control. Operator Barbara Chun, 32, joined the company 5 years ago and has become one of the most skilled seamstresses on the second floor, specializing in complex uniform assembly. Maria Santos, 28, recently transferred from the night shift to spend more time with her young children. Patricia Johnson, 41, works as a quality inspector, moving between floors to check finished products. Helen Rodriguez, 29, operates a high-speed industrial sewing machine on the 4th floor and has been training newer employees for the past 2 years. Nancy Thompson, 36, works in the pressing department, operating steam equipment that requires constant attention and skill. Linda Davis, 25, handles fabric cutting and preparation, working near the large industrial cutting tables. Sarah Wilson, 47, serves as a maintenance coordinator, responsible for ensuring machines receive proper servicing. Janet Miller, 31, works in the finishing department, applying final touches to completed garments. Carol Anderson, 22, recently started as a seamstress after completing vocational training. Margaret Brown, 49, operates specialized embroidery equipment for decorative work. Betty Taylor, 19, is the youngest employee who will perish in the disaster, having started work just 6 months earlier. The morning of March 15th begins like any other at Peachtree Cotton Mills. Workers arrive between 6:30 and 7 a.m., punching time cards at stations near each entrance. The building's heating system struggles to maintain comfortable temperatures as the spring weather brings unexpected warmth. By 8 a.m., the temperature inside the facility reaches 78 degrees, and supervisors authorize the opening of windows on upper floors to improve ventilation. Production quotas for the day call for completing a large order of military uniforms, requiring coordination between multiple floors and departments. The second floor focuses on cutting and initial assembly, while the third and fourth floors handle detailed sewing operations. Workers on these floors operate in close proximity, with aisles between machine stations measuring just 3 feet wide. The noise level makes communication difficult, requiring supervisors to move frequently between workstations to coordinate activities and address problems. At 9:15 a.m., maintenance worker James Patterson notices a small crack in the plaster wall near the main support column on the second floor. He reports the observation to his supervisor, who makes a note to schedule an inspection but takes no immediate action. The crack measures approximately 6 inches long and appears to be superficial damage to the wall surface rather than a structural concern. Similar cracks have appeared before and been repaired with plaster and paint during routine maintenance periods. Throughout the morning, several workers comment on unusual vibrations in the building, particularly on the third and fourth floors. The vibrations seem more pronounced than normal, causing water in glasses to ripple noticeably and making some workers feel slightly dizzy. Supervisor Williams mentions the issue to the plant manager during the 10:30 a.m. production meeting, but the concern is attributed to the operation of new high-speed sewing machines recently installed on the fourth floor. At 11:45 a.m., the building's fire alarm system undergoes its monthly test, sending workers through their practiced evacuation procedures. The drill proceeds smoothly, with all floors evacuated in under 4 minutes. However, several workers note that the stairwells seem more crowded than usual due to increased staffing levels to meet production deadlines. The building's exit capacity, designed for the original 3-floor configuration, struggles to accommodate the current workforce efficiently. Lunch break begins at noon, with workers rotating in shifts to maintain continuous production. Approximately half the workforce remains at their stations while others head to the cafeteria in the basement or step outside for fresh air. The reduced activity during lunch break causes a noticeable decrease in the building's vibration levels, though few workers pay attention to this change. Those who remain on the production floors continue operating their machines at normal speed, maintaining the steady rhythm of industrial textile production. As the afternoon shift begins at 1 p.m., production ramps up to full capacity once again. All floors resume maximum output to meet the day's quotas, with supervisors encouraging workers to maintain their pace despite the increasingly uncomfortable temperature. The building's ventilation system operates at full capacity, but the combination of warm weather, body heat from hundreds of workers, and heat generated by machinery creates stifling conditions throughout the facility. At 1:30 p.m., a facilities maintenance worker conducting routine inspections in the basement notices what appears to be fine concrete dust on the floor near the main structural support columns. The dust appears fresh, suggesting recent movement or stress in the building's foundation elements. However, the worker attributes the observation to normal settling and makes no report to supervisors. The significance of this dust will only become apparent during the post-accident investigation. The critical failure that will lead to 12 deaths begins at exactly 2:31 p.m. when a primary load-bearing beam on the second floor develops a hairline fracture near its connection point to the main support column. This beam, installed during the 1945 expansion, has been carrying excessive weight for 25 years due to the addition of heavy machinery on the floors above. The fracture measures less than an inch initially, but represents a catastrophic failure point in the building's structural integrity. The beam in question, designated as Support Beam 7A in the building's structural drawings, carries the combined load of machinery, workers, and materials from portions of the third and fourth floors. Recent calculations will later reveal that this beam has been operating at 140% of its designed load capacity for over 2 decades. The fracture occurs at a welded joint where the beam connects to the vertical support column, a connection point that was modified during the 1952 expansion to accommodate additional load requirements. As the fracture develops, it creates a redistribution of structural loads to adjacent beams and support elements. The building's steel frame attempts to compensate for the failing beam by transferring weight to parallel support structures. However, these adjacent elements are already operating near their maximum capacity and cannot safely absorb the additional load. The result is a progressive structural failure that will cascade through multiple floors within minutes. At 2:33 p.m., workers on the third floor begin to notice unusual sounds emanating from within the building structure itself. The sounds, described later as groaning or creaking noises, represent the steel framework straining under redistributed loads. Several workers pause their activities to listen, but the noise of operating machinery masks the significance of these warning sounds. Supervisor Williams approaches the area where the sounds seem loudest but cannot pinpoint their source. The temperature inside the building reaches its peak at 2:35 p.m., with readings of 86 degrees recorded on the upper floors. This heat contributes to thermal expansion of the building's steel framework, adding additional stress to already compromised structural elements. The combination of excessive load, structural fatigue, and thermal stress creates conditions that accelerate the progression of the initial beam failure. At 2:38 p.m., Support Beam 7A develops a second fracture, this one measuring nearly 3 inches and extending completely through one of the beam's flanges. The failure of this critical structural element immediately transfers its entire load to adjacent beams, creating a domino effect of structural stress throughout the building's framework. Workers on the second floor directly below the failing beam report feeling a subtle shift or settling sensation, though most attribute it to the normal vibrations of industrial machinery. The building's structural framework now operates in a state of progressive failure, with multiple beams carrying loads far exceeding their design capacity. Engineering analysis conducted after the accident will reveal that at this point, complete structural collapse becomes inevitable. The only question is timing and the specific sequence of failures that will determine the extent of the disaster. At 2:41 p.m., a third critical beam begins showing signs of stress failure. This beam, located parallel to the original failure point, develops visible deflection as it struggles to carry the redistributed load from the failed support beam 7A. Workers in the immediate area notice that the floor feels slightly uneven, with some reporting that their sewing machines seem to rock slightly during operation. These observations represent the final warning signs before catastrophic failure. The progressive structural collapse that claims 12 lives begins at exactly 2:47 p.m. when support beam 7A fails completely, separating from its connection points and dropping several inches. This failure immediately triggers the collapse of a section of the third floor, which crashes down onto the second floor work area. The initial collapse affects approximately 1,200 square feet of floor space, trapping workers beneath falling concrete, steel, and machinery. Within the first 10 seconds of the collapse, the failure propagates to adjacent structural elements as the building's framework attempts to redistribute the massive loads from the collapsed section. 2 additional support beams fail in rapid succession, causing a second wave of floor collapse that extends the affected area by another 800 square feet. The sound of the collapse, described by survivors as like thunder mixed with the screaming of twisted metal, reverberates throughout the entire facility. The third floor section that collapses weighs approximately 45 tons, including concrete flooring, steel framework, machinery, materials, and furniture. This massive weight crashes down onto the second floor with devastating force, punching through that floor's structure and creating a cascading collapse that extends into the basement level. Workers in the affected areas have no time to escape, as the collapse occurs faster than human reaction time allows. As the structural failure continues, a section of the fourth floor loses its support and begins to sag dangerously. While this section does not collapse immediately, it becomes unstable and threatens to fall at any moment. Workers in this area scramble toward exits, but several become trapped when debris blocks their escape routes. The partial collapse of the fourth floor adds additional weight to the already compromised structure below, accelerating the progression of the disaster. The collapse creates a massive dust cloud filled with concrete particles, cotton fibers, and debris that reduces visibility throughout the affected area to near zero. This dust cloud makes rescue efforts extremely difficult and creates additional hazards for both trapped workers and emergency responders. The air becomes thick and choking, adding respiratory distress to the other dangers faced by survivors and those attempting rescue operations. Emergency lighting systems fail in the affected areas due to severed electrical connections, plunging sections of the building into darkness. The combination of dust, darkness, and ongoing structural instability creates extremely hazardous conditions for anyone attempting to navigate the disaster zone. Sounds of shifting debris and occasional secondary collapses add to the chaos and danger faced by rescue workers. The 12 women who lose their lives in the disaster are caught in different areas of the collapse zone, with most unable to escape due to the speed and extent of the structural failure. Dorothy Williams, working near the main collapse area on the third floor, becomes trapped beneath falling concrete and steel. Barbara Chun, operating her sewing machine on the second floor, is overcome when the floor above collapses directly onto her workstation. Maria Santos and Patricia Johnson, working in adjacent areas, are caught in the initial wave of debris and do not survive the impact. Helen Rodriguez, working on the fourth floor, becomes trapped when her escape route is blocked by fallen structural elements. Nancy Thompson, operating steam pressing equipment, is overcome by the collapse before she can reach safety. Linda Davis, working near the cutting tables, is struck by falling machinery and succumbs to her injuries. Sarah Wilson, conducting maintenance rounds, is caught in the collapse while attempting to help other workers evacuate. The remaining victims, Janet Miller, Carol Anderson, Margaret Brown, and Betty Taylor, are all working in areas directly affected by the structural failure and are unable to escape before being overcome by the collapse. The investigation will later determine that all 12 women died from trauma sustained during the building collapse, with most succumbing immediately to the impact of falling debris and structural elements. Emergency response to the disaster begins within minutes of the collapse as workers throughout the facility immediately recognize the magnitude of the catastrophe. The plant's emergency alarm system activates automatically, though many workers in unaffected areas initially assume it is another routine drill. However, the sounds of the collapse and the visible dust clouds quickly make clear that a genuine emergency is occurring. The first emergency responders arrive at the scene at 2:52 p.m., just 5 minutes after the initial collapse. Columbus Fire Department crews immediately establish a command post and begin assessing the extent of the disaster. The sight that greets them is devastating. A massive hole in the building where 3 floors have collapsed into the basement, with twisted steel beams, concrete slabs, and machinery creating a chaotic pile of debris. Rescue operations begin immediately but face enormous challenges due to the unstable condition of the remaining structure and the massive amount of debris that must be cleared to reach trapped workers. Heavy equipment is brought in to stabilize the building and begin the careful process of removing debris while searching for survivors. The operation requires extreme caution as additional structural failures could occur at any time, potentially trapping rescue workers as well. Search and rescue teams work methodically through the debris pile, using specialized equipment to detect signs of life and carefully excavating areas where survivors might be trapped. The process is painstakingly slow due to the need to shore up unstable sections and the risk that heavy machinery could cause additional collapses. Every piece of debris must be carefully removed to avoid causing further harm to anyone who might be trapped below. Medical teams establish triage areas both inside and outside the building to treat injured workers as they are rescued from the collapse zone. Ambulances from throughout the region respond to transport the most seriously injured to hospitals, while less severely injured workers receive treatment at the scene. The medical response is complicated by the number of casualties and the difficulty of accessing injured workers in the unstable building. The immediate aftermath of the collapse reveals the full extent of the tragedy as rescue workers systematically account for all personnel who were in the building at the time of the disaster. The death toll becomes clear as bodies are recovered from the debris. 12 women have lost their lives, while 23 others suffer injuries ranging from minor cuts and bruises to serious trauma requiring hospitalization. 8 workers sustain critical injuries and are rushed to intensive care units at regional hospitals. The cause of death for all 12 victims is determined to be trauma from the building collapse, with workers unable to escape before being overcome by falling concrete, steel, and machinery. Medical examiner reports indicate that most of the victims died immediately upon impact, sparing them prolonged suffering. The technical cause of death is listed as multiple traumatic injuries sustained during structural collapse, reflecting the devastating force of the falling debris. The scene after the collapse resembles a war zone, with emergency vehicles, heavy equipment, and hundreds of rescue workers surrounding the damaged building. The collapsed section creates a crater-like depression filled with twisted metal, broken concrete, and the remains of industrial sewing machines and other equipment. Dust continues to settle hours after the initial collapse, coating everything in a fine layer of concrete and cotton particles. Environmental concerns arise immediately due to the potential release of industrial chemicals, machine oils, and other hazardous materials stored in the facility. Environmental teams assess air quality and water contamination risks while rescue operations continue. The collapse has also severed gas lines and electrical connections, creating additional safety hazards that must be addressed before full access to the site can be achieved. The local community responds with an outpouring of support for the families of the victims and the injured workers. Churches, civic organizations, and individual citizens organize relief efforts to provide food, shelter, and financial assistance to those affected by the tragedy. The disaster strikes at the heart of the close-knit industrial community, where many families have multiple members working in the textile industry. Media coverage of the disaster brings national attention to workplace safety issues in American manufacturing. Television news crews and newspaper reporters descend on Columbus to document the aftermath and investigate the circumstances that led to such a devastating structural failure. The images of the collapsed building and the human cost of the disaster shock viewers across the country and prompt calls for improved industrial safety regulations. The investigation into the fatal collapse begins immediately, led by a team of structural engineers, safety experts, and state officials. The investigation team includes representatives from the Georgia Department of Labor, the State Fire Marshal's Office, and independent engineering consultants with expertise in structural failures. Federal investigators also join the effort as the disaster raises questions about the adequacy of existing workplace safety regulations. Investigators focus on determining the root cause of the structural failure and identifying any factors that contributed to the loss of life. The investigation involves detailed analysis of the building's structural design, construction history, maintenance records, and inspection reports. Engineers conduct extensive testing of materials recovered from the debris to determine if substandard construction or deteriorated structural elements played a role in the failure. The investigation reveals that support beam 7A, which initiated the collapse, had been operating under excessive load for over 2 decades. Calculations show that modifications made during building expansions in 1945 and 1952 placed loads on the original structural framework that exceeded design specifications by significant margins. The beam that failed was never upgraded to handle the increased load requirements from additional floors and heavier machinery. Metallurgical analysis of the failed beam shows evidence of fatigue cracking that developed over many years of operation under excessive stress. The investigation determines that the fracture began as a small crack that gradually propagated through the beam's cross-section until it reached a critical size that triggered catastrophic failure. This type of failure is predictable and preventable through proper inspection and maintenance programs. The investigation also uncovers a pattern of deferred maintenance and ignored warning signs that contributed to the disaster. Records show that structural concerns had been raised multiple times over the preceding decade, but were not addressed due to cost considerations and concerns about production interruptions. The investigation concludes that the collapse was entirely preventable and resulted from a failure to properly maintain and inspect the building's structural systems. Expert testimony during the investigation reveals that proper engineering assessment would have identified the structural deficiencies years before the collapse occurred. The investigation determines that a comprehensive structural evaluation, recommended multiple times but never conducted, would have revealed the dangerous condition of support beam 7A and other structural elements. Such an evaluation would have cost less than $50,000 but could have prevented the loss of 12 lives. The investigation also examines the building's evacuation procedures and emergency response capabilities. While investigators find that emergency procedures were generally adequate, they note that the speed of the structural collapse made evacuation impossible for workers in the immediate collapse zone. The investigation recommends improved early warning systems and structural monitoring to provide advance notice of potential failures. Investigators determined that the collapse sequence began with the failure of support beam 7A and progressed through a predictable pattern of cascading structural failures. The investigation creates detailed computer models of the collapse sequence to understand how the failure propagated and why it affected such a large area of the building. These models help identify design and maintenance practices that could prevent similar failures in the future. The legal consequences of the disaster unfold over several years as families of the victims pursue wrongful death lawsuits against Peachtree Cotton Mills and the building's structural engineers. The lawsuits allege negligence in maintaining the building's structural integrity and failing to address known safety concerns. Legal proceedings reveal internal company documents showing that cost considerations repeatedly trumped safety recommendations. Criminal charges are filed against company executives for criminal negligence and willful violation of safety standards. The charges allege that company officials knew of structural problems but failed to take corrective action, directly contributing to the deaths of 12 workers. The criminal proceedings focus attention on corporate responsibility for workplace safety and the consequences of prioritizing profits over worker protection. The wrongful death lawsuits result in substantial settlements for the families of the victims, though no amount of compensation can restore the lives lost in the preventable tragedy. The settlements establish precedents for corporate liability in structural failure cases and provide some measure of financial security for the families who lost their primary breadwinners in the disaster. Regulatory agencies impose significant fines and penalties on Peachtree Cotton Mills for safety violations and failure to maintain adequate structural integrity. The company is required to completely rebuild the damaged sections of the facility to current safety standards and implement comprehensive structural monitoring and maintenance programs. These requirements add millions of dollars to the cost of the disaster, but establish important precedents for industrial facility management. The disaster prompts immediate changes in Georgia's industrial safety regulations, with new requirements for regular structural inspections of manufacturing facilities. The state legislature passes the Industrial Building Safety Act in 1971, mandating annual structural assessments for all facilities employing more than 100 workers. The law also establishes criminal penalties for willful neglect of structural safety requirements. Federal workplace safety legislation, already under consideration in Congress, gains momentum following the Peachtree Cotton Mills disaster. The Occupational Safety and Health Act, signed into law in December 1970, includes provisions specifically addressing structural integrity requirements for industrial facilities. The disaster becomes a case study in the development of OSHA standards and serves as an example of why comprehensive federal safety regulations are necessary. The textile industry implements significant changes in response to the disaster, with trade associations developing new guidelines for structural assessment and maintenance of manufacturing facilities. Insurance companies begin requiring more frequent and comprehensive structural inspections as a condition of coverage, creating market incentives for proper facility maintenance. These changes help prevent similar disasters across the industry. Engineering schools incorporate the Peachtree Cotton Mills collapse into their curricula as a case study in structural failure analysis and the importance of proper maintenance and inspection programs. The disaster serves as a powerful example of how engineering decisions have real-world consequences and the professional responsibility engineers bear for public safety. The case study helps train future engineers to recognize and address potential structural problems before they become catastrophic. The families of the 12 women who lost their lives in the disaster work to establish a memorial scholarship fund to help other women pursue education and career opportunities. The Dorothy Williams Memorial Scholarship, named for the senior supervisor who died in the collapse, provides financial assistance for women seeking vocational training in industrial trades. The scholarship program ensures that the victim's legacy includes positive opportunities for future generations. The site of the collapse is eventually rebuilt with state-of-the-art safety systems and structural monitoring equipment. The new facility serves as a model for industrial safety design and includes advanced warning systems that can detect structural problems before they become dangerous. A memorial plaque in the lobby honors the 12 women who died and serves as a permanent reminder of the importance of workplace safety. The long-term impact of the Peachtree Cotton Mills disaster extends far beyond the immediate tragedy, fundamentally changing how American industry approaches structural safety and maintenance. The disaster demonstrates that workplace safety cannot be separated from structural integrity and that both require ongoing attention and investment. The 12 lives lost in the collapse serve as a catalyst for improvements that protect countless other workers in similar facilities. Current industrial safety standards incorporate many lessons learned from the Peachtree Cotton Mills disaster, including requirements for regular structural inspections, load capacity monitoring, and predictive maintenance programs. Modern facilities use advanced sensors and monitoring systems to detect structural problems before they become critical, providing early warning that can prevent catastrophic failures. These technologies, developed partly in response to disasters like Peachtree Cotton Mills, represent a significant advance in industrial safety. The disaster also highlights the importance of corporate culture in maintaining workplace safety. Companies that prioritize short-term profits over long-term safety investments create conditions where preventable tragedies can occur. The Peachtree Cotton Mills case becomes a landmark example of how corporate negligence can have fatal consequences and the legal and financial risks associated with inadequate safety programs. Training programs for facility managers and safety professionals now include extensive coverage of structural integrity issues and the warning signs of potential failures. The disaster serves as a powerful example of why safety professionals must have the authority and resources to address structural concerns promptly and effectively. Professional certification programs for industrial safety specialists include case studies of the Peachtree Cotton Mills collapse as required learning. The families of the victims continue to advocate for improved workplace safety standards and serve as powerful voices for the importance of putting worker safety ahead of production pressures. Their testimony before legislative committees and safety boards helps ensure that the lessons learned from the disaster continue to influence policy and regulation development. The personal stories of loss and tragedy provide human context for technical safety discussions. The 12 women who died in the Peachtree Cotton Mills collapse were not just statistics or casualties of industrial progress. They were mothers, daughters, sisters, and breadwinners whose lives were cut short by preventable negligence. Dorothy Williams, Barbara Chun, Maria Santos, Patricia Johnson, Helen Rodriguez, Nancy Thompson, Linda Davis, Sarah Wilson, Janet Miller, Carol Anderson, Margaret Brown, and Betty Taylor deserve to return home safely to their families each day. Their deaths serve as a permanent reminder that workplace safety is not optional and that every worker has the right to a safe working environment. The tragedy teaches us that structural integrity cannot be compromised for economic convenience, and that warning signs must never be ignored when lives are at stake. The disaster demonstrates how seemingly small decisions about maintenance and inspections can have catastrophic consequences when they accumulate over time. The collapse shows that safety is not just about individual behavior, but requires systemic attention to the fundamental systems that protect workers from harm. The legacy of the Peachtree Cotton Mills disaster lives on in the safety standards and regulations that protect millions of American workers today. The 12 women who lost their lives did not die in vain if their sacrifice leads to better protection for others. Their memory serves as a constant reminder that behind every safety regulation is a human story, and that the price of neglecting workplace safety can be measured in lives lost and families destroyed. If this story about preventable tragedy and lost lives gave you insight into why safety matters, leave your like and share with others who appreciate learning from fatal accidents so others might live.